In this video, we are going to take a look at truth tables. So in particular, we're going to look at the truth tables for conjunctions. Those are the and statements. We're going to look at the truth tables for disjunctions. Those are the or statements. And we are going to look at the truth tables for the negations. Right? Those are the not statements. Right? So let's first look at the conjunctions. Right? So with a conjunction, we are looking at P and Q. And so we have a statement P and a statement Q. Our notation, we use that P, and then we have that caret or that mountain, however you want to describe that. So we have P and Q. When we have a conjunction, we would say in a truth table, the conjunction P and Q, this is only going to be true if both P and Q are true. Right. So if I were to say something like, I teach math and I have $1 billion, then you would say, no, that's not true. Even though you teach math, you don't have $1 billion. Right? But if I were to say, I teach math and I have at least $10, then that would be true. I do have at least $10 and I do teach math. Right? So for a conjunction, this will only be true if both P and also Q are true. So we can make these truth tables. So this will be our first truth table that we create. When we create a truth table, we will have a truth value for P. We have the truth value for Q. And then we're going to have the truth value for that conjunction, P and Q. So we could have true, true. We could have P is true and Q is false. We could have P is false and Q is true, or both of them being false. And so based on those, we can then identify what is the truth value of P and Q. Right? And so for P and Q from up above, we said it's only true if both P and Q are true. And so here we have true, true. So since both P and Q are true, then the conjunction P and Q is true. In every other setting, right, here we have true, false. We have at least one of them false. False, true, at least one is false. False, false, at least one is false. They're both false there. And so each one of these other ones in that truth table, these will all be false. So that's for the conjunction. That's for our and statements. Now for the or statements, for the disjunctions, when we have P or Q, notationally we write that as P, and then it looks like the letter V, Q, P or Q. This is going to be false if both P and Q are false. And it's only false if both P and Q are false. So a truth table for this is going to look kind of similar in some ways, at least in the initial setup. So we have our truth value for P and our truth value for Q. We're going to find then, based on that, the truth value for P or Q. So we can have true, 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 false, false, true, false, false. So those are all of our options. And so from up here, we see that it's only going to be false if both P and Q are false. And so when we write this truth table, it's going to be false down here, but everywhere else we have at least one of those two things as true, and so the truth value for that or statement is true, right? If I were to say, I'm a math teacher or I have $1 billion, you would say, yeah, that's true because you are a math teacher. It doesn't matter that the second part, me having $1 billion, is false. It only matters that one of the two pieces is true. If I were to say, I'm a math teacher or I have at least $10, you would say, yeah, that's also true, even though both of those pieces are true. And so that's our truth table for an or. And then we're going to do a quick truth table for a negation. And so for this negation, if we were to say not P to create that truth table, all the negation is doing is it's changing the truth value. So the truth value for P, it could have either been true or false. And so when we negate it, we have the opposite truth value. And remember, all of these are statements, P and Q, and because they are statements, that means that they definitely have a truth value, either true or false. So that's it for our initial truth tables. In our next video, we will look at some examples where we build some more complicated truth tables. All right, we will see you there.